here we have the next example in terms of CLT floor-to-wall connection design, but with balloon type and steel L beam as a connector. And why this connection is interesting, because it's being used regularly across some of the mass timber buildings, but it's also challenging in terms of all the specific verification, because regularly user would either neglect or calculate some of these parts of the design partially or by hand or with spreadsheets. What we automate here and make bigger flexibilities in terms of verifying both axial and lateral capacity of screws in the same time. So here we have the reaction forces from some of the CLT wall that's being supported by CLT wall. So we added or modified our example to have some wall shaft in the middle of our building. We have here how this detail works, and what is interesting about this, we have a reaction force from a CLT wall, and we decompose this and try to figure out not only what are the lateral capacity or lateral force acting on screws, but also what are the tension force because of the eccentricity. So here is the decomposed picture and explanation of how we calculated the tension on the screw as well. I can show you this in details how this works. So I already have set up the geometry. For the first member, I select the steel plate. For the second member, I have CLT selected. Again, for the connection type, we have continuous option. So I want to know what is happening with the design of this per meter, and also side grain is selected. If we look up our 2D imagery, we can see what is happening with the geometry overview in both directions and sections. And also if we go into 3D, we can see, so this should represent one leg of our L beam, and also with appropriate length. We have the thickness of our CLT wall, 180 millimeters, and we have forces in the direction of this line, and also tension that's acting on these screws. If we go into detail, so in this case on the loading data, I've applied 12 kilonewton per meter for the X direction and 18 kilonewton per meter for the Z, or the tension that is applied for per meter on this connection. In terms of design methodologies, so Eurocode, again, all of these recommended values, and I modified some of the things, so it's according to the example we have. In terms of the member data, so you can here configure what is the plate thickness, but also select what CLT data you are using. So in this case, I wanted to show KLH, 5 layers, 180 millimeters that thick CLT. And going further, we have option for selecting fasteners. So in this case, I've chosen the Schmidt screws. Already filter out according to steel to timber. So you can see when you select here what are the compatible and incompatible screws. So based on the recommendation and implementation process with our supplier, we filter out what are the screws applicable for specific scenarios. And in this case, you can select appropriate diameter and length. So in this case, we have 8 millimeter diameter and 120 millimeter length of screws. Eurocode, current Eurocode 5 is selected, standard arrangement, so we don't worry about the distances, but just to show you how this works. So if you go with manual input, you have everything unlocked and you can play with that if you want. But in this case, I'll go with standard arrangement. I've set up 6 screws per meter and we have 1 row. And you can see how software limits you according to your geometry, so you can select more than 2 rows in this case. In terms of the results, we have here information about screw geometry, shear capacity, axial capacity, also combined actions and slip modules. So why is this module is so good is that you can also not just verify separately shear and axial capacity, but see what's happening with the combined actions at the same time. So if we go into screw geometry verification, we can see separately what are requirements for axial and laterally loaded screws. So again, something that is being verified, and there is a recommendation and requirements for both. If we go in the axial capacity, we can see all the details and results according to that easily. Similarly with rope effect, shear capacity and design capacity. So we have here verified what is the axial and lateral capacity of this connection. And last part is related to combined action. So this is something that is also included. For some advanced more connection and demands from engineer, you can always see what is the stiffness or slip modulus of connection. So you have data for that as well.